Hello, today we are going to be looking at the 6 different trig functions of a right triangle. You already know 3 of them from geometry, sine, cosine, and tangent. So let's go ahead and start there. We know that if we're looking at the sine of an angle, that relationship, that trig ratio, is the opposite side over the hypotenuse. The cosine is the adjacent leg over the hypotenuse, and tangent is the opposite leg over the adjacent leg. Now, again, that's review. Our new content, our new trig functions, because we said we had 6 and that's only 3 of them. We have cosecant, secant, and cotangent. Your cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, the cosecant is the hypotenuse over the opposite, and again, we call this is the cosecant. Secant is the reciprocal of cosine. So this is going to be the hypotenuse over the adjacent. This is secant. And the cotangent, which is the reciprocal of tangent, so we have the adjacent leg over the opposite leg, and this is your cotangent. So to find those, we just did the reciprocal. We flipped the numerator and the denominator. So another way to think of the cosecant is 1 over the sine of theta. Theta is just your angle measure. Secant is 1 over cosine of theta. And cotangent is 1 over tangent of theta. Depending on the situation that you're given, one might be easier to use than the other. So those mean the same thing. So let's go ahead and evaluate the 6 trig functions of a triangle. When I look here, I've got my right angle. That is necessary. I've got this side is 10, this side is 8. We are missing the hypotenuse. I need to know all 3 sides in order to find all of my trig functions. I don't just do an x and fill in my ratios with x. That's not good. I can find that third side. So I do my leg squared plus leg squared is equal to the hypotenuse squared. 10 squared is 100. 8 squared is 64. When we go to put this together, we realize that this is not a perfect square. You are not going to use the decimal. We are going to use exact answers. So we break down the 164 with our factor tree. 4 and 41. I know I can use any 2 factors of 164. I could have done 2 and 82. 41 is a prime. So if we remember, when we break down our factor tree, it's matched pairs make perfect squares. The leftovers stay on inside the radical. So this becomes 2 square root 41. The hypotenuse of that triangle, that missing side, is 2 root 41. When we look at our triangle, there is our theta. That is our reference angle. So when we're talking about opposite versus adjacent versus, hypotenuse is always going to be there, but opposite versus adjacent, it's in respect to that angle position. So when I see sine of theta, just as a reminder, that's opposite over hypotenuse. 10 is going to be the side across from, so opposite that angle. 8 is adjacent. And then what we just found, that 2 root 41 is the hypotenuse. So opposite over hypotenuse. And of course, we know that we're not going to leave that as our final answer. I can see on the outside, 10 over 2 reduces down to 5 on top. And then we're going to rationalize. So this is all algebra review. Nothing new here. We know how to simplify a radical, outside numbers together, inside numbers together. We know how to rationalize, so we rationalize there. The cosecant is just the reciprocal of that. Now, I'm not going to use my final answer. I'm going to look back one step. Because when I do the reciprocal there, it's the square root of 41 over 5. And I don't have to rationalize. If I would have taken my final answer, it would have been a lot more work to do. All right, so moving on to cosine, that is your adjacent over your hypotenuse. Again, those outside numbers reduce down to 4 on top, root 41 on the bottom. And we rationalize, giving us 4 root 41 all over 41. Again, when I'm doing my secant, the reciprocal, I go back a step. Again, it's just going to make my life easier rather than using the final answer for cosine. And then finally, some easy ones. Tangent opposite over adjacent reduces down to 5 over 4. Cotangent, 4 over 5. No worries about having to rationalize anything there. So sine, cosine, tangent, those are our reviews from geometry. Cosecant, secant, cotangents are the reciprocals of what we already knew. Our next section is how to use your calculator. If you don't have your calculator out yet, go ahead and push pause and grab it. When you look at your calculator, you see right there in the middle, there's a sine button, a cosine button, and a tangent button. But when we look at our notes, I'm not asking for sine, cosine, tangent. I'm asking for secant, cosecant, and cotangent. So here, we're going to use that reciprocal relationship. So if I want to evaluate in my calculator the value of secant of 40, I do 1 over cosine of 40, because secant is the reciprocal of cosine. We don't have a secant button to push, so I've got to use what we've got. So it's 1 over cosine of 40. And we would round, but that's not the right answer. I'm going to double check something real fast. I'm going to hit mode. There's my issue. So when we're working on this right now, we're always going to be working in degrees. So you hit that mode button, which is right next to second, and we arrow down. Right now my calculator is in radian mode. I don't want it to be in radian mode. I arrow over, I hit enter, and I make sure that it is in degree mode. If it's not in degree mode, all of my answers are going to be wrong. So I do 1 over cosine of 40 again, and I get 1.305 as my answer. So for number 2, if I'm looking for cosecant of 32, cosecant is the reciprocal of sine. So I do 1 over sine of 32. Back to the calculator, 1 divided by sine 32. We don't have to worry about checking it because we know that we have it in degree mode. 1.887, that 0 tells me that it's going to stay as 1.887. And our last one, cotangent, is the reciprocal of tangent, so we do 1 over tangent of 88. 1 divided by tangent 88. 0.034, that 9 tells me that the 4 is going to round up to a 5. All right, our last question, an application word problem. We are going to have a lot of word problems. A tree cast a shadow on the ground that is 50 feet long. The angle of elevation from the end of the shadow to the top of the tree is 53 degrees. How tall is the tree? Round answers to the nearest tenth. So again, in geometry, we had angle of elevation and angle of depression. That is going to come in with a big rule again. So we've got our tree, which is a fabulous tree. It is going to create a shadow. Shadows are not in the air. Shadows are on the ground. So when I go to label my right triangle, there's one right there. That right triangle, the shadow is 50 feet. The angle of elevation from the end of the shadow to the top of the tree is 53. Labeling the angle in the correct location is really important because it's all about the relationship. What side is opposite? What side is adjacent? Which side is the hypotenuse? So having the correct labels in the right spot is going to change which trig function you use. And the question is, how tall is the tree? There's my unknown. Here is my reference angle. I'm looking for x, which is opposite, and I'm given 50, which is the adjacent. So I think about which trig function relates opposite and adjacent. You do have two options, tangent or cotangent. Just because we learned all these 6 new trig functions doesn't mean we have to use cosecant and secant and cotangent. I'm going to go old school. Opposite over adjacent is tangent. So we have tangent of our angle measure is equal to the opposite side over the adjacent side. Again, this is right here. This is 100% geometry review. To solve for x, that becomes x equals 50 times the tangent of 53. Back to our calculator, 50 tangent 53. We find that rounding to the nearest tenth, 66.3, that 3 is going to round up to a 4 because of the 5. So that's going to be about 66.4 feet. We do have a word problem, so we're going to make sure that we are always labeling our answer with the correct labels. All right, that is it for this video.